In this video, we'll show how to deploy a job with TrueFoundry. So we are going to be training the MNIST digit recognition model in this particular training job. And the way we deploy the job to TrueFoundry, you'll be able to pass parameters to the job in every run. For example, you can have the hyperparameters be different every time you run the job. So that is what we're going to show in this video, and we'll be using the ML Foundry library to log our experiments as well, and to log the model as well. So yeah, let's get to the code. So in the first step, I have to install the ML Foundry and Service Foundry libraries. So we've already discussed the ML Foundry library and how it's used for logging the metrics and parameters. But in this video, we'll also use it for logging the metrics. Service Foundry is a library that is used for deployment, and to deploy the job to TrueFoundry, we'll be using the Service Foundry library in this video. So I've already run the install command. And now let's get to the login stage. So I'll just have to log in by generating an API key. So I can just follow this link. It'll take me to the API key page. I'll create a new demo key. Just copy the value, close this, and I'll paste the API key here. And I should be logged in right now. Now I need to provide the workspace FQN. This is required for the rest of the code to work because we want to deploy the job in a certain workspace. So we'll use our MNIST workspace that we created before. So I'll just enter the FQN. So to copy the FQN, you can just go here and copy the FQN from this using this button, and after that you can paste it here. So we're just simply saving that FQN in a variable here. Now let's get to the actual training script for training the MNIST digit recognition model. We'll be using the Keras library for building the model. If you're not familiar with the Keras library, or if you're not familiar with training deep learning models, that's fine, because the concept that we cover in this video is applicable across all sorts of machine learning models and their training processes. So you can follow the rest of the video even if you don't understand the exact structure of the model itself, or how exactly the model is getting trained. First thing we do is we create a ML Foundry client object, and for the client object we create a run. The name of the project is MNIST classification, and this particular run is named test run. So I have the run object here, which I'll be using through the rest of the code, through the rest of the training script. So then I have my data pre-processing where I create the training and the test set, which is like standard process when you're training a machine learning model. And then I have the model object itself, and you can see that I'm using a sequential model from Keras with a bunch of layers in it. It's a deep learning model, as you can see. And then finally, I have the model.fit, which is basically the training step where you take the training data and the output for the training data, and then fit the model on that particular set of inputs and outputs. You can see that I'm passing this metrics log callback to this callbacks parameter. So metrics log callback is actually a class, and this class can define a bunch of functions in that, like on epoch end, which actually, as the name would suggest, is called at the end of each epoch. So when you do model.fit on a deep learning model, you usually run it across multiple epochs, and here I've set the number of epochs to one. But when I set it like a larger number, then it'll repeat the training process as many times as the number of epochs. And I want to log metrics at the end of each epoch, so I know when to stop training, maybe, or when to sort of checkpoint the model, and all that sort of logic depends on my metric at the end of each epoch. So what I can do here is on each epoch end, I can log the metrics using the run object, the ML Foundry run object, using this callback, using the help of this callback that I defined here, and using the help of this callbacks parameter. I'm also logging the parameters that I'm using, including batch size and epochs. So these are like a couple of the hyperparameters that I want to log. So we are logging the parameters here, we are logging the metrics here, and we are logging the model itself here. So let's run this. So it says the project MNIST classification does not exist. So it actually creates the project and then it creates the run. So as you can see that the first epoch is underway. You can see that the validation accuracy is around 95%, which is pretty good. Even for one epoch, we get a pretty good accuracy using this model. So now we are getting the ML Foundry logs where we are logging the model itself. It says login model and additional files. So packing and uploading files to remote, which means the model that we just trained, the weights and everything, It's getting uploaded to ML Foundry, so we have the model saved in the model registry, and we can use it later as well. So we'll for that to finish, and yeah, it's completed. If I go to the ML repos page, you can see the MNIST classification repo is created, and inside that there's a test run, and you can see the hyperparameters that we set. The batch size is 512, the number of epochs is 1, and you can see the metrics as well. You can see the metrics including loss, accuracy, validation loss, and validation accuracy. And if I go to the models tab, I should be able to see model as well because we log the model at the end of the training script. So you can see the model here as well. The next thing we'll do is we'll deploy this job onto TrueFoundry. There are a few reasons why you might want to deploy a job. One, maybe you don't want it to run on Collab. You want it to run on your own cloud. So in case if you deploy it using TrueFoundry onto your cloud, then your data will not leave the bounds of your organization's cloud. The second reason might be you want to save this job for running it again. For example, you might want to save this job so that you can run it on a different data set or maybe with different hyperparameters. The way you can do this is by parameterizing the job. Maybe you can take out some of the inputs to this job as parameters and deploy it onto Foundry. And then every time you run it, you can provide the values for these hyperparameters and the other parameters as required. And another reason might be that it only costs you the amount of time the job takes to run. You won't be charged for before or after that job. So it's useful to save some cost during the job training process. And finally, by running the model onto Foundry, you basically have very tight integration with the model registry and with the model deployment workflows, which makes it easier for you to save the model, to load the model, to deploy the model as a service, etc. So how do you deploy to Foundry? That's what we'll see in the following blocks. So the first thing I do is I create train.py script, which is pretty much like the script that we ran above where we train the model. The only difference here is that I'm using an argument parser here to get some hyperparameters in. So the hyperparameters that I'm getting in is convolutional filter, the number of filters for the convolution layer 1, a number of filters for the convolution layer 2, and the batch size. So as you can see that instead of the fixed value that I used in the previous script, these are now taken from the argparse library. So this can be provided to this particular training script as parameters while running Python main.py or Python train.py in this case. So you can see that I'm using args.conf filters one here in the conf2d object. Again, for this different convolution layer, I'm using the number of filters that is stored in the variable conf filters two. And you can see that the batch size is getting picked up from args.batch size. So what I've essentially done is I've parameterized the script so that these parameters can be provided while running the script. So, and you can see that I've not, you can also see that I've not run this particular script this time, but instead I've used the write file magic command to create a file called train.py. So I create train.py so that we can use this script to deploy this job to TrueFoundry in the next step. Then I also created a requirements.txt file with the libraries that are required for this particular script to work. They include NumPy, Scikit, ML Foundry, and TensorFlow. The next thing you actually do is deploy the job to TrueFoundry. Before we deploy this job, we need to actually do a couple of things with the workspace. The first thing is to increase the limits of the workspace because we've already deployed a couple of services before, and now we're going to deploy a job that takes up a bunch of resources. So we'll increase the size of the workspace. The other thing we'll do is we'll attach the ML report to this workspace because once you start running this script inside the TrueFoundry job, what happens is we'll have to log the model as well using the ML Foundry library, and the permission does not exist for that workspace or for that service to write to that particular ML repo. But by connecting the ML repo to the workspace that we're working with, we'll be able to grant the script the permission to write to ML Foundry repo, the ML repo that we want to write to, which is the MNIST classification repo that we created. To make these changes to the workspace, we'll go to the workspace tab, and the workspace is MNIST workspace. So we'll click on the edit button. Once that opens, we'll increase the CPU limit to maybe 10, the memory limit to 20,000, and the storage limit to maybe 10 GB. So that should be sufficient limits for the rest of the demo. And the other thing we have to do is we have to associate the ML repo that we just created, the MNIST classification repo, with this particular workspace. So we'll add an ML repo. We'll choose the MNIST classification repo that we just created, and we'll give admin permissions for now. And let's update the workspace. So now the workspace is updated, we should be able to go forward with the rest of the deployment. Now we can finally get to the deployment. To deploy this job, we've created the train.py file and we've created the requirements.txt file. Now we'll use a service foundry library to actually create the job and deploy it. So first thing we'll do is we'll create the job object. We import this from service foundry library and we provide it with the name train MNIST. And then we also give it instructions on how to build this. So it's a Python build since we are essentially running a Python script. So we'll use the Python build object here. And you have to provide the Python version and the requirements to path.txt, which is requirements.txt in this case. Finally, we come to the command. To run this particular script, we have to call python train.py with the hyperparameters conf filters 1, conf filters 2, and batch size. Instead of actually passing a value here, we will have placeholders that this command is parameterized, and we actually provide the params in a list here. So you have the params, and we provide three params here, which is the conf filter 1, conf filters 2, and batch size again. And in the command, we just have placeholders that will be replaced during the execution. And we also provide the resource that has to be allocated for this particular service, for this particular job. So we set the CPU limits, memory requests, and so on and so forth for this particular job. Once that is done, we do job.deploy, and that should initiate the deployment of this job onto the TrueFoundry platform. Notice that this will only deploy the job. It will not run the job, and you have to trigger the job to make it run. So we'll get to that eventually. But at this point, we've just triggered the deployment. The code is getting uploaded, and the deployment is underway. So if I follow this link, okay, the build is completed and the status is suspended, which means we are ready to run our job. So we'll open this run job. We'll click on this run job button, and this run job menu opens up. Here you can pass the hyperparameters. You can configure the hyperparameters. For example, these are the default values. Maybe you can change them, and then I can trigger the job as well. We'll not trigger this job in this video. In the next video, we'll trigger this job with multiple different hyperparameters. We'll see how the corresponding models are getting created, and we'll compare between those models.